So for our second example, which again is going to be a rocket problem, it says, what is the highest point reached by an object thrown with a speed of 4 meters per second at 40 degrees to the horizontal? So here is our scenario. We have some object. It's going to be traveling initially upwards at 4 meters per second. I'm going to make that a little longer just so we can have a little bit more room to work. So not a very fast initial velocity, but we do know it's at 40 degrees. It's asking for what is the highest point reached, right? So if we look at the path that this is going to take, it's going to have some path that looks like this. And this right here would be my highest point. That's going to be my SY. So again, we're going to break information into X and Y apart. We're going to look at this and say, well, we have some initial velocity in the X. We have some initial velocity in the Y. If I look at this, because we're 40 degrees, I should know initially that my velocity in the X initial should be greater just slightly than my initial velocity in the Y. If it was 45, they'd be equal. But this is a way that I can kind of, as I'm going through, hey, does this answer make sense? Does it match this understanding? So that's the first thing that we're going to do, is we're going to break our X and Y, or break our total velocity into our X and Y. So our first thing we're going to do is find initial in the X and initial in the Y. Really, for this problem, we only need initial in the Y, so let's do that. This is the opposite side of my angle. This is my hypotenuse. So I'm going to use the sine of theta equals initial velocity in the Y over my initial velocity total. I'm going to solve for initial velocity in the Y, so I'm going to multiply each side by the total velocity. Gets those away, and we're left with initial velocity in the Y equals my total velocity times the sine of theta. That's going to be 4 times the sine of 40. And that answer is going to be 2.57 meters per second. All right, so that's my initial velocity in the Y. So I'm going to bring my information up here and say, okay, my initial velocity in the Y is a positive 2.57. We know our acceleration in the Y is going to be a negative, I'm just going to use negative 10. We're looking for really how high, right? So that's my main goal. We're going to know that my velocity in the Y direction at the very top, right here, that is 0 at the very top. And we don't know the time. So with this, because I have 4 different variables and 3 of them are known, I should be able to find this value there. So the second process of this is simply going to be find SY. And with what I know, I'm going to use the equation velocity squared equals initial velocity squared plus 2 acceleration times displacement. And again, these are all going to be in the Y direction if I'm looking for the maximum height that is reached. I'm solving for S. I know that my final velocity is actually 0, so that's going to go away, and then I'm going to subtract my initial velocity to both sides. And so I should get a negative initial velocity squared, and again, the negative, let me write it like this, the negative is outside the squared, right? So initial velocity squared negative equals 2a SY. I'm going to divide each side by 2a. It gets rid of this side, and I'm left with SY equals negative UY squared over 2a. Now, why that's important is because when we plug this in, some things should cancel out. It's going to be a negative, and then this is going to be, what do we say, 2.57 squared divided by 2 times negative 10. My negatives here should cancel out. And so this should just become 2.57 squared divided by 20. When I solve for that, I'm going to get a height of 0.33 meters. Don't forget to square this, and so that's my maximum height. Now, again, looking at this, that's not very high, right? But we got to remember, this is a problem where something is only being launched at 4 meters per second, and it's at an angle. So it's really only being thrown up at 2.57. So I'm not even really going to get 1 meter above where I'm actually launching it. So not a big value, but that's okay. As long as we work through the problem, we should be successful in that.